Suppose you flip 1,000 coins, what is the probability of getting exactly 500 heads and 500 tails? Okay, so here we are dealing with very large numbers, so when we try to figure out the probability, we're gonna set it up the same way we were doing in the previous section. We were gonna figure out the multiplicity of all the combination of all the microstates, and then we'll use the formula that I've derived in a video. If you're interested to see how you can reason that out, watch my video in combinatorics. Here I will just use the formula as is. And then we will set that up, but then we are gonna hit some very large numbers which most calculators are unable to do. So then we will invoke the Stirling's approximation in this section to try to figure it out. So let's get it started. We know that if we flip 1,000 coins, so I'm doing part A, the multiplicity of all, well, each coin can be either head or tail, so each coin has a 2, the 2 microstates that it can be in, and then the second coin also has 2 heads or tails, and the third coin has 2 all the way till I reach 1,000 coins. So this is just going to be 2 to the 1,000. Okay, now if I'm trying to do 500 heads and 500 tails, so that will be the probability of 500 heads will just be the multiplicity of getting 500 heads divided by multiplicity all, right? And we've already actually, yeah, let's just use the formula as is. We've already derived that. That's equation number that is equation number 26 in your book to get multiplicity of 500. So let me write it down. So we're gonna use if we have n, choose n. This is just n factorial. I made a video showing you how to reason this out. You could watch it for more detail on how we got here. Factorial. Okay, which is what you hear it says, how you hear it said, and choose n. Okay, so in this case I have 1,000. I have 1,000 and I'm choosing 500, so this will be, so capital N is 1,000, small n is 500, so just fill into the formula. So this is 1,000 factorial over 500 factorial times 1,000 minus 500 is 500 factorial. Again, we're dealing here, 1,000 factorial is all the numbers multiplying each other till you get to 1,000. Most calculators will not be able to do that, so here we will invoke Stirling's approximation, yeah, and so we will get, let me show you. So that's equation in your book. That's equation 214 that says if I need to simplify any factorial, n factorial, that is the same thing as n to the n, e to the minus n, 2 pi n. At some point when I get around it, I will do a video on how to actually derive that. For now, let's just use it as is. This is equation 214 in the text. So with that said, that means 1,000 factorial will just be 1,000 to the 1,000 e to the minus 1,000 square root 2 pi times 1,000. Okay, and then likewise for the 500. square root that's a minus, yeah, okay, so okay, plug all that in, so we will get on the 1000 choose 500, we will get 1000. So the 1000 factorial, I'm writing it as simplified through Stirling's approximation. So this one in green here is called Stirling's approximation. Okay. Okay, so 2 pi 1000 divided by now this is just repeated twice, so I will square each one. So 500, when I square 500 to the 500, this becomes 500 to the 1000, right? To the 1000, and then this becomes e. If I square this, becomes e to the minus 1000, because I'm squaring each one. And here we have 2 pi times 500. Square goes away, so immediately we notice that these guys go away, and one of these goes away, so we are left with 1000 to the 1000, and here I have 1000 to the half. Wait, let me 1000 to the 1000. Over 500 to the 1000, and then here we have square root of this left, so this is 2 pi times 500 to the half. Okay. Now so this is equal to, now this is 500 to the 1000 is a very large number. 2 pi times 500 to the half is a large number, somewhat of a large number, but it's negligible compared to 500 to the 1000. So I'm just gonna ignore this, because you know all you're gonna add here is 1000.5. okay, so this could be ignored, and then we get 1000 raised to the 1000 over 500 raised to the 1000. So that means I can, so both of these raised to the 1000, and this is the same thing as 2 raised to the 1000. Okay, fair enough. Now I'm gonna go back. Remember, I have a factor of 2 to the 1000 in the denominator, so actually I didn't have to ignore these. You know what, let me leave the denominator as is so we can get a somewhat more accurate answer. It's fine. So I'll just leave here 2 pi square root 500. We can deal with that. we don't need to ignore it to make this work, because I just realized we have 2 to the 1000 in the denominator. So now that means the probability, so plugging into the probability here, dividing them, we will get probability of getting 500 heads will be 1500. This is what we got here, 2 to the 1000 divided by 2 pi square root 500 divided by 2 to the 1000. Oh yeah, I couldn't have ignored them, because had I done that I would have gotten a 1, which is not very reasonable, yeah, because these guys will completely cancel out. So I will get 1 over 2 pi square root 500. Alright, so what's this here? I'll punch this on the calculator. Okay, I just noticed there was a mistake here. 1 second. First of all, this is 2 pi to the 1/2. Let me use the same color. I was trying to put this on the calculator at the same time I'm writing it down, so I forgot a few terms here. So this is 2 pi to the half, and then we have square root 1000 over 500. So this is square root 1000 over 500. Okay, and then these terms will carry over, so this is to the half, and this here is supposed to be square root 1000 over 500, which would carry over here. I apologize. So this will be square root 1000 over 500. Okay, corrected. So plugging this in, we will get, now it's reasonable. Now any calculator can handle this. Uh, 0.02523. So this is the probability of getting 500 heads, and simplified using Stirling's approximation. Okay, let's do the second part. The second part is what's the probability of getting 600 heads and 400 tails. So it's the same thing, except instead of 1000 choose 500, it's gonna be 1000 choose 600. So let's do part B here, and then I'll divide it by the multiplicity all, which is the same. So now we have 1000 choose 600. So this is gonna be 1000 factorial divided by 600 factorial times 1000 minus 600 would be 400 factorial. Okay, again, let's invoke Stirling's approximation on these. So since I did it in detail on the first one, I'll just fill it in now. So for 1000, the 1000 factorial is going to be n to the n. So that's let's actually continue here, because this might be a long one. 1000 to the 1000 times e to the minus 1000. square root 2 pi 1000. Okay, and then same thing on each one of these, except replace the 1000 with 600, so we get 600. And then the 400. So this whole thing is the 1000 choose 600. Okay, right? Okay, let's see. Here we might need to consider another approximation, but let's see if we can get away without it. We have some very large numbers and none of them add up, correct? This is times, or they actually do. We could cross out e to the minus 1000 here with this guy, so those go away, and then we have left 1000 to the 1000, right? Okay, so let me show you what we're gonna do here. This is the probability or the multiplicity of getting 600 heads. Okay, so I'm gonna get 2 pi. Now this here, I could cross out a 2 pi, just the 2 pi with this 2 pi, and then I still have on top 1000 square root 1000 divided by 600 to the 600, and then I have square root 600, and I have a 2 pi and a 400, so 600 times 400 and a 2 pi here, and then I also have 400 to the 400. Okay, what I'm gonna do to this equation, I'm gonna use, because these are large numbers that calculators can't really handle, so I'm gonna ln both sides. Okay, and the reason I could ln, probably I should have ln both sides from the first step, and the reason for that is I could right, n factorial is just n to the n e to the minus n. Right, and yeah, I probably should have. Okay, well, it's fine. You know, I got to this point and there's not much I could do. These calculators aren't able to handle these, so what I'm gonna do, look, since things didn't really work nicely as part A, where things really canceled out, because here I didn't get to the 10,000 or whatever. So I'm gonna go back to this step here, okay, and I'm gonna copy it, and I'm gonna use a different approach here. And what I'm gonna do, so this left hand side here is the probability of getting 600 heads, okay, and I'm gonna use another kind of approximation where I'm gonna ln both sides, okay, and let me show you why. So ln (600), so this is gonna be ln 1000 factorial minus ln 600 factorial minus ln 400 factorial. And the reason I did this is because there is a nice way to approximate ln n factorial when n is very large, that just boils down to its equation 216 in your book, nlnn minus n. So once the first method fails, you can always resort to this one, because you know we have all factorials here, so I could use that to simplify each one of these. So this is gonna become 1000 ln 1000. 1000 factorial is definitely a very large number, and it qualifies for that approximation. Minus 1000. I might want to start here at the beginning. So this is 1000 ln 1000 minus 1000 . Okay, that's the first one. And then the second one, 600 ln 600 minus 600. And then the last one is 400 ln 400 minus 400. And now we can definitely use a calculator to figure these out. And because you know ln 1000 is easy, so plug this into your calculator and let me do that. I haven't done that. I didn't expect I'm gonna use this. It came up to 670. Yeah, 670. Oh wait. No, I have a mistake here. Shoot. Okay, so I accidentally typed 10 instead of 1000, so the answer is 673.012. Okay, and now I'm trying to get this, so I could just this would be E or actually wait, because this is still going to be a larger number. Let's go to the answer now. So we know that the probability of getting 600 heads will just be the multiplicity of 600 divided by all. Okay, and so this is gonna be and then here, because I already have ln of this, I'm gonna ln both sides again. So I'm gonna say ln the probability is equal to ln the right hand side, which will be ln this, which I already have, 673.012, minus ln this, which is a very large number as well, so it will simplify it along the way and I could deal with it. So this would be 673.012, and this is what we got in part A. This is 2 to the 1000, I believe. Yeah, 2 to the 1000. So ln 2 to the 1000, and you could see how useful this is, because this is just gonna, the 1000 will come down, and the calculator can definitely do this. So this is ln the probability, and I can solve for the probability at the end. So I get here minus 20.13, and so the probability of getting 600 heads will just be e to the minus 20.13, and this any calculator should be able to handle. We get 1.8 times 10 to the minus 9. Approximately 1.799 times 10 to the minus 9. It's a very small probability that you will get 100 more coins in 1,000 coin, 100 more coins of one kind than the other. As we saw on the graphs, as we get away from somewhat the average number, the probability drastically drops. Okay, I hope this helps give you a sense of how useful Stirling's approximation can be in dealing with this large number, with these large number of mathematics at hand, and how to utilize these tools to try to simplify them and come out with a useful result. This concludes the problem.